Welcome everybody. I don't see how many people are in the audience. I welcome you all. I work at Humboldt Universität zu Berlin as well as Helmholtz-Zentrum Berlin. And we're talking about inkjet-printed metal halide perovskite devices in our next talk. We are having numerous activities in that field. Let's start, like the line here through the talk is inkjet printing. The selected structured deposition using inkjet printing in particular drop-on-demand technologies offers for the industrial process. In particular, the on-the-fly registration, the low investment barrier, rapid prototyping. And there are a couple of processes already implemented in industrial processes, and we are trying to work on the forefront of that, optimizing processes, making it possible to print devices or partially printed devices. Always having to optimize in that case if you're not in the inkjet printing business. At the end, it's about throughput, of course, and for that you have to optimize the inks with the surfaces, substrates, formulation with the printhead. Now, that's the short outline. I will go from the electrodes over to some special things which you can do with metal halide perovskites, in particular the combinatorial printing process, which is really making a change and giving us new opportunities far beyond that what has been achieved with inkjet printing. Now, we have heard already in the last talk that transparent conductive electrodes are something we need in many different applications, being it in sensor applications, being it in light-emitting devices, in solar cells, in all these thin film devices, and it has been motivated already in the last talk. In addition, we want to go into flexibility, flexible devices, and as we know what is used currently, the indium tin oxide is working well, but it's of course associated with high cost, and it's not flexible, it's brittle. So there are different approaches, as you can see here, from starting with nanowires, polymers, but in many cases you need more lower sheet resistance, more conductivity on that surfaces. And here comes inkjet printing. We have seen the metal grids in the past talk, and what we are doing is we print the metal grids. We can do that with silver. Just printing them with that thin film devices would be not enough. You need also to embed them so that you optimize your devices such that you don't have a disadvantage with the printed metal grid. We can do that with silver. We can do that with copper. What is a new trend now in inkjet printing, to go away from printed nanoparticle inks into particle-free inks, so metal decomposition inks. As you can see here, very simple formulations. The advantage is you have no sedimentation, no clogging, you have a longer shelf lifetime of your inks, and they are easier to work with. You can easily make them yourself or have a very simple approach into the chemistry and formulation, since there is no sedimentation of the particles or of any particles anymore. So it's easier to work with it on the printer. And on the other hand, we also can go away from the traditional either infrared or flash curing process to processes which use plasma, which are easier to be used in inline processes. So the process is very simple. You print, then you go on over that with a plasma, and you get then the converted metals. And you can use that for interconnect, you can use that for wiring, but you can use that if you make the metal layer very thin. Also for flexible conductive electrodes, as you can see here, what we have demonstrated here for LEDs. And the important point is, it's now as good as ITO, but in addition it's flexible. As you see here from the bending test, typically ITO has a problem after 20 cycles of bending, and